In this video, I will be showing how you can use runMultiple inside Microsoft Fabric notebooks to do notebook-based orchestration. Coming from the old school world of SSIS and SQL Server, and later Azure Data Factory and Azure SQL Database, I have always built my ETL orchestration processes using some kind of pipelines. In Fabric, we also have pipelines, the successor of ADF, but we can now also create notebook orchestration using NotebookUtils and runMultiple. In ADF, I always made sure to have a metadata-driven pipeline for orchestration, with a configuration database in which information is stored that describes the ETL processes that we are to run. My old framework consisted of a description of source systems tables and optionally table columns to extract, including things like incremental loads, configuration of API endpoints, and so on. This is where you will find all the latest tips and tricks on using Microsoft Fabric. Nowadays, we do the same thing in Fabric pipelines in order to orchestrate the ETL process that loads data through the medallion architecture. However, if you start running notebooks with for each loop from pipelines, you will quickly run into an error saying that you have too many concurrent Spark sessions. So that really doesn't work. How can we fix this? As a way around, we could use notebooks to orchestrate parallel processing loads in Microsoft Fabric. We will use a Python package called NotebookUtils that is created by Microsoft. Specifically, we will use the method runMultiple in this package, telling the notebook to start multiple notebooks in a certain fashion, parallel or sequential with dependencies and so on. Let's dive into my laptop to see the demo. Alright, and here we are looking at the demo. We are inside Microsoft Fabric. We're looking at my Fabric Guy workspace, and what we see here is a very easy setup in order to demo the runMultiple. We have a lakehouse and we have two notebooks because with runMultiple I always create an orchestrator workbook and a worker notebook, and then I let the worker do the work while the orchestrator orchestrates the process. Alright, so the lakehouse is nothing special. This is just an empty lakehouse and that's it. And the orchestrator and the worker notebook is where the magic happens. So now what I've prepared for you today is a worker notebook that expects in a parameter cell two values, the table name that we are going to load and a payload in JSON format that we are going to put into a Delta table. Okay, then when we start doing the actual work, I first will parse my my JSON payload into an object that I can actually loop through and put into a data frame. Using spark.createDataFrame, I will create a Spark data frame out of the JSON payload. So for every row in my JSON, I will create a row in the data frame, and then we will write the value of the data frame to a Delta table. We will overwrite the table if it already exists. And we will save the table as the table name that we've put in the parameter in here. So this is actually quite a simple demo for runMultiple, but it at least showcases that we can have a very flexible and variable way of loading data into a Delta Lake. So then let's look at what the Orchestrator notebook actually is doing. Here's the Orchestrator notebook, and this Orchestrator notebook I will start by creating the objects that I want to load. I've called this tables, and tables is a list of tables in this case, and every tuple in the list has a name and a payload. And I think we've created 3 tables in here. We created a users, customers, and products table, and they contain columns such as ID, name, and source, or customer ID, company name, country, and so on. So there's different schemas for these demo tables. And then again, this data usually will come from APIs or databases or files or anything like that. This is not where you would want to put data manually into your notebook, but just for the demo, this is something that we could easily do in order to show how runMultiple works. So we have the Orchestrator notebook here. We defined the list of tables that we want to load. Next is we need to declare a list of activities, and then we will use those activities to be executed. All right. So we declare an empty list of activities first, and then we start adding values to that activities list. All right. How do we do that? We start looping over my tables list. So for every table in tables, I will create an activity and then put that activity into the activities list by using activities.append. The activity itself contains a few different things. It contains a name, a path to the worker notebook, and it contains arguments. And these are probably the most important thing that you will put in. The arguments here are the parameters that the worker notebook is expecting. So you will find here the table name and the payload JSON that we are actually passing through to the worker notebook. Now then, at the end of it, we will have a complete list of activities. In this case, there will be 3 activities in that list. And then we will create our DAG, or directed acyclical graph. You can forget about that name, it's not that important. But at least we will create the DAG and we will execute that by saying, okay, the activities are the list of activities that we just have, and we can put some concurrency or timeout in seconds in there. And now when we start running this cell, you can see that the worker notebook is now being executed in parallel 3 times with 3 different activity names for users, customers, and products. And when it is done, I will probably have, if the demo gods are nice to me today, I will have 3 tables in my lakehouse. And indeed, I have 3 tables in my lakehouse in here, and they all have 3 different schemas, just as we expected. Now let's say that we have changed something in here. We will put in not just a source, but also a theme, and we can say, let's say theme, and then we will put in theme A in here, and we will put Jane in theme B. And now when we run the cell again, this cell will overwrite the existing users table. There will be another column that's being added right there. Okay, so now that all of the tables have loaded again, we can start refreshing the users table here. Refresh that. And there we have the theme that is new. So now you know how to use runMultiple to orchestrate processes in PySpark notebooks with Microsoft Fabric using the NotebookUtils package and runMultiple. And if you like this video, please like and subscribe to my channel. Like the video and subscribe to the channel, because that will help me teach you guys more things about Microsoft Fabric. I will be here every week with a video on Thursday. See you next time.